पहले फर्स्ट लगा दो। इससे पहले वाली है अभी, ठीक, तब तक तो हो जाएगी, बैकग्राउंड में करते रहो। Good afternoon. Today we are going to start atomic physics, right? The last chapter of class 12th for your boards as well as the IIT JEE. So let's start with the important results, which I believe we can show the slide. Let's see the important results. Right. Slide दिखाना. Okay. Just have a look at them. These are few of the important results. You can write them. At least write this part. This is important. For your preparation, this is important. Like for example, angular speed. It is directly proportional to square of the atomic number. Indirectly proportional to, inversely proportional to cube of the principal quantum number. There are few of them which I would write for you. You can write down these two important results also. Just take the right hand side. Important is the right hand side. These are two more important results. This is called R naught. This is a constant value. It's a fixed value. Similarly, this is a constant value. then there is an important result of linear speed, tangential speed. You can also write it down. This is you can say that Vn is directly proportional to Z by N. The important point about this expression is that this expression of mass of the electron. Sometimes in the JEE, you are simply asked, I would not include N in this value is value 137. Sometimes they can simply ask you what is the value of C by 137. And this constant is also 2.19 10 to the power 6 meters per second. Now, there are certain results which help you in calculation, in fast track calculations in atomic physics. One of them is this. What is R? Rydberg constant. But do you know that value of R can also vary? You feel it's a constant? It can also vary. The value, all these values which I've calculated, you have taken an assumption. And the assumption is that the mass of the electron is very, very small as compared to the mass of the nucleus. That is why we assume that electron is moving around the nucleus. All these calculations are based on this presumption. That is why we do not have mass of the nucleus in any of these terms. But if you get a question, I'll give you a question like that, where mass of the nucleus or mass of the electron is comparable to the mass of the nucleus, then all these expressions, the results change. R, the Rydberg's constant. So in all the expressions, when you use R, instead of R, you use R infinity. Now, this term signifies that we are calculating the value of Rydberg's constant when mass of the nucleus is infinite as compared to the mass of the electron. And RCH is 13.6 electron volts. This is a very interesting relation. Is that clear? R infinity CH is 13.6 electron volts. Now, as I was telling you, that in all these expressions, if mass of electron is comparable, then what would happen? In that condition, what you do is, you first of all change the value of R. Now, the value of R becomes R infinity plus 1 plus m by m. Note it down. Let's understand what this result tells you. This is R infinity upon 1 plus m by m. In this case, m is mass of the electron. And capital M is mass of the nucleus. Perfect? Now, if mass of the nucleus is very, very large as compared to mass of the nucleus of the electron, this will become infinity. the whole thing will become 0, and the value of R becomes R infinity. Right? That is the first change. So when mass of the electron is comparable, this is going to be the first change. R infinity will become R. That's one. Two, wherever you have M, you have M here, you have M here, replace M by mu reduced mass, where mu is going to be equal to mm upon m plus m. So in all the expressions where you have a small m, you can practically replace this by capital M, by reduced mass mu. Okay? Let's take down a question which will really help you. Likho. A positronium atom is a system that consists of a positron and an electron that orbit each other. Now, this statement itself is self-explanatory, right? If mass of the nucleus, say this is nucleus, and this is electron, and that's your radius. If this mass is very, very large, then electron will move around this nucleus. But if the mass of the nucleus is comparable to that of the electron, in that case, this will have a center of mass close to the nucleus. Now, what will happen is this nucleus will move, and with respect to the center of mass, this electron will also rotate. Since the nucleus, the center of mass, and the electron lie on one straight line, you can take this as one rigid rod. The angular velocity of this, and angular velocity, that means the angular velocity of the nucleus with respect to the center of mass, and the angular velocity of the electron with respect to the center of mass, both those angular velocities will be same. Note it down, please. Right? If you look at this question, this also tells you a positronium atom is a system that consists of a positron and an electron. Now, interesting line, that orbit each other. Now, when I say they orbit each other, that means they are orbiting with respect to their center of mass. Now, he says compare the wavelengths. Compare the wavelengths of the spectral lines. Compare the wavelengths of the spectral lines of the positronium with that of ordinary hydrogen. Solve it. So wherever the mass comparison takes place, okay, you use a normal R, and wherever there is an infinite nucleus, you use R infinity. Now you can solve it. What is the value of R? R infinity upon 1 plus small m by capital M. Yes. Now, when I said positronium, it says consists of a positron and an electron. That means which means the value of the Rydberg's constant reduces to half, right? Which means we also know that energy, अगर वो energy की expression पूछता, you know that E by E infinity is R by R infinity. That means energy also reduces to right? We also know that lambda is inversely proportional to energy, or maybe energy difference. Therefore, lambda will become 2 times lambda infinity. This becomes an important tool, important question for your entrance exam. Clear? Okay? Okay. Now, let's take another situation. If I were to ask you to fill in the blank, N1, N2, total energy, kinetic energy, or I would take this as potential energy and total energy. Can you fill in the blanks? For a hydrogen-like atom, or I would say, let's take a hydrogen atom itself. That means Z is 1. Can you fill in the blanks? First of all, do you know this expression? What is the interrelation between all these three? Bolo? Yes? Can I say Kn is negative En? And can I also say Un is 2 times? Yes? What is the value here? What is the value for n equals 2? बोलो बोलो कितना होता है 10.2 और 10.4 जल्दी बोलो कितना और इसे 3.4 हाँ minus 13.6 by 4 is minus ये याद होना चाहिए वैल्यूज ठीक है 13.6 इलेक्ट्रॉन वोल्ट्स 3.4 इलेक्ट्रॉन वोल्ट्स ये डबल होता है कितना हुआ minus 27.2 electron volts minus 6.8 electron volts. Perfect. If I add both of them, I get this relation. Now, first of all, let's understand. Is this result true for all cases? This is only true when your force is inversely proportional to R square. Number one. If in a question they give you a force which is not proportional to 1 by R square, I'll take a question in which we'll take a hypothetical system where force does not vary as 1 by R square, then all these expressions will change. That is, point number one. Right, Tejaswini? Point number two is, now in this question, this is one energy, potential energy is one energy which is frame dependent. We regard that at infinity, the potential energy is zero. यही है ना? ये नहीं, ये नहीं है. क्या है? What is the reference? एक सिचुएशन लेते हैं. You'll understand it. Let's take a situation. Assume, लिखो, assume that the potential energy at n equals 1 is 0. What will be the corresponding energies of both these orbits? N equals 1 and n equals 2. For them, what would be their corresponding values? करके दिखाओ. If I take n equals 1 as zero potential energy state, सोचा कुछ? अब see, when you get a question in the exam, you have a limited time. That means your thought process in the very first attempt has to be absolutely correct. The thought process will develop by the way the question is asked. बोला जाता है ना that the solution lies in the problem itself. Now in this question he says that the potential energy of n equal 1 is 0. ये कैसे possible है? If I were to add तभी 0 होगा ना? अगर n equals 1, n equal 1 पर मैं इतनी एनर्जी एक्स्ट्रा दे दूं, कैसे? रेफरेंस को चेंज करके. If I'm assuming that u at n equals 1 is 0, इसका मतलब ये पॉसिबल तभी है ना जब इसके अंदर मैं इतना वैल्यू ऐड करूंगा. राइट? डू यू थिंक दिस विल चेंज? Kinetic energy is frame independent or dependent? Frame dependent. This will not change. This cannot change. That means this does not change. This becomes 0. What is the total value? लिखो. And write the logic also. Kinetic energy will remain the same. Potential energy, by reference you made it 0. Therefore, it is the total energy which will change and the potential energy which you have changed. Right? Achha, now, when you're giving this energy, you gave energy to all the quantum numbers, not just one. That means आपने यहां पर भी दिया 27.2 electron volts. ये एनर्जी कितना बन गया? What is the energy here? 3.4. So this becomes your new energy paradigm. Is it clear? This is situation number 2. See, everybody knows what is Bohr's model. And everybody can remember the results of Bohr's model. So what difference or what different questions are going to come in JEE? A, they would test you whether do you know that the results which have come are based on an assumption. Now, all the students would know this result. But do we know that this is dependent when force is 1 by r square? And if F minus du by dr can be applied, only then can we use them. Or all these expressions are based on a premise that at n equals 1, we take potential energy, which is a reference, as minus 27.2 electron volts. If I change this, how things will change? Or if the mass of the electron is comparable to mass of the nucleus, how would that hypothetical system look like? So they are going to test you. J will test you on the assumption part. Numerical part will follow. Is that clear? So when I say concepts, it means you should know the assumptions which are behind those things, and if those assumptions change, how do those results change? इसीलिए 90% students who cram results in questions are not able to solve because they forget the assumption. And when we talk about assumptions, people think it is derivations. Important derivation nahi hai. Isme, if you remember even these results, you can manipulate them. You know small m can be replaced by mu. R we always thought was constant. It is not R, it's R infinity. अब इसी को मैं एक further और लेके चलते हैं आगे. Suppose on the same thought what we are discussing right now. Now we know what is the value of energy. Potential energy is minus 1 by R, constant by R with a negative sign. Imagine if potential energy is this expression. We change the expression. Now he says, find the radius of the nth orbit. What changes would you do and how would you solve this problem? Suppose potential energy, what would be your first step? Change it into F? Yes or no? कितना हो जाएगा force? Tick, right? This is equal to, it is moving in a circular orbit. Right? In any Bohr's model, in any Bohr's assumption, one assumption is always going to remain true, and that is the angular momentum is n times h by 2 pi. You cannot change this assumption. So this becomes your equation 1. This becomes your equation 2. Now you can solve them, solve both these equations and find the value of R. What is the value of R? क्या है? What is Rm equal to? Clear? This is one part of Bohr's model. Now we can go on to the slides and see how we can solve these questions. Okay, have a look at this. First question. If I were to say that it's a multiple choice question, more than one options are correct. What are the possible correct options? Follow? Is the first option correct? Check your results. Radius. Is it directly proportional to n square? Yes or no? Yes. Second, Is the second option correct? Yes or no? No. Is the third option correct? Yes. Is the fourth option correct? It is. Potential energy is twice the kinetic energy. So the correct options will be A, C, and D. Okay. Next slide. He says the ratio of the areas within the electron orbits for the first excited state, you need the ratio of the electron orbit area ka ratio of the first excited state to the ground state of hydrogen atom. Can you do that? Karo, try karo. Yes. The correct answer is 16:1. The option A is correct. ठीक है ना? Why? Why do you say so? Yes. Yeah. 16/16:1. Correct. Third slide. Very good. The innermost orbit of the hydrogen atom has a diameter this. The diameter of the 10th orbit will be. I think we will use the same. Yes, radius is directly proportional to n square. Radius will be directly proportional to n square. And twice of radius will be the diameter. Since ratio we are taking, so what would be the correct option? D. Yes, the right option is D, 106 angstroms. Good. Next slide. The energy of the electron in the nth orbit of the hydrogen atom is given by this. The amount of energy needed to transfer electron from the first to the third orbit is. Jaldi karke dikhao. How much energy is required? You say C. Tejaswani says the answer is C. Okay. कैसे बोलते हो तेजस्वनी बताओ? E1 कितना है? Yes. And what is E3 equal to? कितना हुआ? 1.5 electron volts. And we need the difference. And the correct answer is 12.09 electron. Perfect. Next question. If the binding energy of the electron in a hydrogen atom is 13.6, you know what is binding energy? The amount of energy which is required to liberate the electron. He says is 13.6. The energy required to remove the electron from the first excited state of Li plus 2. Lithium plus. लिथियम प्लस 2 का Z कितना होगा? Very good. When he says first excited state means N1 becomes 2 and N2 becomes, है ना? So what is the answer? 30.6 electron volts. So the right and the correct option is B. Very good. Next question. Tell me the ratios of the wavelengths from state 2 to state 1 transition in Li plus 2, helium plus 1, and hydrogen atom. I want the ratio. Can you tell me the ratio? The transition is same, N1 and N2 are same. So if you have to find relation, what is the relation you actually need? The relation between lambda and Z. By the way, what is the relation between lambda and Z? Who can tell me? 2 lambda is inversely proportional to Z square. So you know the values of Z, right? Tell me what is the answer? Yes. 4:9:36. And the option is C. Next slide. Energy E of a hydrogen atom is given by this. The energy of a photon ejected when the electron jumps from n equals 3 to n equals 2 is how much? It's a very simple question. It requires fast calculation. You already know the concept, you remember the formula. What should be the answer? Yes. Tejaswani is absolutely right again. It's again 1.9 electron volt. ठीक है ना? Simple? हो गया? Next slide. In a Bohr's model of hydrogen atom, let RVE represent the radius, the speed, and the total energy of the electron. Which of the following quantity is proportional to principal quantum number? Now, this question will require, what would it require? It would require, do you remember the formula? Let's see. The formulas I've given you, you can directly use them. देखो किसके बराबर आ रहा है? Tejaswani is again right. The correct option is D. Now, that means इस question में कोई concept नहीं था. आपको सिर्फ formula याद होना था. So if you remember the formula, you directly can solve it. So E is RV. इसको अब आप एक formula की shape में लिख लो. E is RV. Next slide. Chalo, this looks very simple. The question says the energy of a hydrogen atom in the nth orbit is represented by En. Orbit of a singly ionized atom will be. Energy के ऊपर Z square आता है ना? Singly ionized कितना हो गया? 2. Yes. Singly ionized helium atom का मतलब क्या हुआ? Z कितना हुआ? 2. है ना? Z square कितना हो गया? 4. So the answer will be 4En. है ना तेजस्विनी? Yes. Next question. Next slide, please. Okay, have a look at this. It says that the wavelength of radiation emitted is lambda naught when an electron jumps from the third to the second orbit of the hydrogen atom. For the electron jump from the fourth to the second orbit of the hydrogen atom, the wavelength of the radiations emitted will be. What's the answer? Right. Absolutely. Absolutely right. 20 by 27 lambda naught. Again, formula based, right? Achha, now, let me discuss a very interesting thing in as far as it goes conceptually. What do you mean by hydrogen? When I say hydrogen spectrum, it has Lyman, it has Balmer, it has Paschen, Pfand. Visible part कौन सा होता है? Balmer, right? So Balmer series is the visible part of the spectrum. Okay. Now, Balmer series is also represented by H alpha, H beta, H gamma series. Like for example, if he says find the wavelength of H alpha, okay, let's understand. This is N1, this is 2, this is 3. What is the value of 1 by lambda? It's R infinity CH 1 by N1 square minus 1 by N2 square into Z square. मैंने बताया था ना, RCH is nothing but 13.6. यही होता है. ये कुछ गड़बड़ है. Is there something missing? Is this the value of 1 by lambda? Is something missing or is it correct? I want you to check it. Yes, this is study. है ना? What is missing in this case? देखो, आप बताओ पहले. Let me see. Is this one? See, is this correct? And what is equals? So that means E by HC will be. So that means if I divide this by, इसको मैं नीचे ले आऊं, this should become 1 by. So this is the correct result. Understood? ठीक. ये स्टूडेंट्स मिस्टेक करते हैं, इसलिए मैंने आपको लॉजिक बता दिया किस तरह से करते हैं. नाउ इफ आई वांट द एच अल्फा, एच अल्फा का मतलब पता है क्या होता है? क्या लिखोगे आप? 1 by lambda h alpha is r infinity 1 by 2 square minus 1 by if I this is h alpha. What is h beta? 4 to 2. One by 2 square minus 1 by 4 square. Perfect. Next slide, please. Okay. Have a look at the question. When an electron in hydrogen atom is excited from the fourth to the fifth stationary orbit, the change in the angular momentum of the electron is how much? Angular momentum is nh by 2 pi. Only the value of n will change. करके दिखाओ. कितना आ रहा है? C 1.05 10 to the power minus 34. आपका भी C आ रहा है? दोनों का सही आ रहा है तो फिर गलत कैसे हो सकता है? Right option is absolutely right, is C. Great. Next slide. In hydrogen atom, if the difference in the energy of the electron in n equals 2 and n equals 3 orbits is E, what is the ionization energy of the hydrogen atom? Solve it. What do you think is the significance of this question? Whenever you get a problem in atomic physics in JEE, if they don't mention the energy of the first state, do not take that energy as 13.6 electron volts. You take it as something as a constant. एक वैल्यू को कांस्टेंट ले लो. समझ में आया बात? हाइड्रोजन एटम की बात कर रहा है तो Z तो 1 हो ही गया. Correct option is B. तो जिस तरह से तेरे सारे सवाल ठीक हो रहे हैं, इमेजिन कर जेई के दिन भी ऐसे हो जाए. ऐसा नहीं होता. अब फिर अभी ऐसे क्यों हो रहा है? राइट. तब टेंशन होती है. तो उसका मतलब टेंशन जब होती है तो तुम्हारा पेपर खराब होता है. तो मतलब टेंशन नहीं लेनी है. See, it's just an examination. And you will have so many examinations in your life. If you start taking the stress of every examination, तो पूरी लाइफ स्ट्रेसफुल हो जाएगी. If you have intelligence, which you have worked hard, You understand things. Just be yourself. Just be yourself. ऐसे ही सोचो कि एग्जामिनेशन हॉल में बैठे हो आप. If the same thing goes, you're going to get full out of full marks. तो पूरे मार्क्स आने 120 में 120. क्यों टेंशन ले रही है? चल, next question. In Bohr's model of hydrogen atom, the ratio of the periods of revolution of an electron in n equals 2 and n equals 1 orbits is how much? Did I give you the expression for time period? Formula याद है आपको? Check करो. How does t vary with n? Check करो result. लिखाया था मैंने आपको. क्या लिखा था? What was t? How was t dependent? T is directly proportional to n cube. होता है ना? So if t is directly proportional to n cube, so what will be the ratio? 8:1. Correct? So the right option is. Now what happens is generally exam में लोग इसको derive करने लगते हैं, and that is where they kill time. You have to remember certain results. ठीक है? Next slide. In a doubly charged lithium atom is equivalent to hydrogen whose atomic number is 3. The wavelength of required radiation for emitting electron from the first to the third Bohr's orbit will be how much? Now see, in this question, hasn't he mentioned that the ionization energy of hydrogen is 13.6? So that means you don't have to take any other value. करके दिखाओ. You remember the formula? You remember 1 by lambda is R infinity, right? 1 by n1 square minus 1 by n2 square. याद है ना? Into z square. क्या आंसर आ रहा है? कैलकुलेशन को फास्ट करो. स्पीड अप, स्पीड अप. What is the closest result? क्या रहा है? Closest क्या रहा है? कैलकुलेशन बहुत ज्यादा है. I don't think so. So fast करो. Is it the D option? Close आ रहा है D के? Yes? Yes. Next slide. Okay, we can leave this. Let's go on to 16th. We have very less time. Have a look at this question. Interesting. थोड़ा different thought है इसके अंदर. In this case, says hydrogen atom emits blue light when it changes from 4 to 2. 5 to 2 per, if it was a blue light for 4 to 2, what the color of the light would be from 5 to 2? सोच के बताओ. Now in this question you practically don't have to write it. सोच के बताओ मुझको एक बात. Visible spectrum clear है विबग्योर है ना? Now when you jump from 4 to 2 or you jump from 5 to 2, पहले मुझे बताओ एनर्जी डिफरेंस ज्यादा किसमें है? पक्का लैम्डा कम हो गया. If the energy difference is more, then lambda is less, and if lambda is less, you move towards left. So अगर blue था तो क्या आएगा? Violet. So the right answer is D. So in entrance exam you can also have questions like this. Clear? Next slide. Have a look at this. A single electron orbits in a stationary nucleus of charge this. It requires 47.2 electron volts to excite electron from the second to the third Bohr orbit. What is the value of Z? You can assume 13.6 electron volts as your ionization energy. What is the answer? Approximate कितना आ रहा है? What is Z square equal to? Approximately 25. Z कितना आ रहा है? 5. Yes. Very good. The right answer is 5. Absolutely fantastic. Acha, we'll have to go back to the first slide. I gave you 2 mind maps, right? Second mind map को देखेंगे अब दोबारा ध्यान से. Next slide. इसके अलावा next, इसको ध्यान से देखो. थोड़ा इसको zoom कर सकते हैं? थोड़ा zoom करिए. Okay. Let's see. पहले ऊपर वाला फॉर्मूला नोट करो. It's interesting formula. लिखो. It actually tells you that if electron has to shift from one orbit to the other, then the corresponding value of lambda is how much? आप ये लिखो. Lambda equals, write the second one, n1 square upon 1 minus n1 square by n2 square into r. ये लिखो आप. Right? अब इस रिजल्ट का एडवांटेज देखो आप क्या है. ये लैम्डा आ गया. Remember this result. ठीक है? Now, suppose I come to the Lyman series. ठीक? Tell me one thing, even in this formula, if I were to ask you maximum wavelength ट्रांजिशन किसी सीरीज का, सपोज लाइमन की बात करो, तो n इक्वल्स 1 से n2 का क्या वैल्यू होगा जब वो वेवलेंथ मैक्सिमम होगा, है ना? जब एनर्जी डिफरेंस मिनिमम होगा. तो एनर्जी डिफरेंस मिनिमम कब होगा? जब 2 पे जाएगा. एंड इफ आई वर टू आस्क यू व्हाट विल बी द मिनिमम वेवलेंथ, n2 will become infinity. So now this expression can be remodulated into lambda max and lambda minimum. इसकी वैल्यू लिखो, lambda max की वैल्यू लिखो, and lambda min की वैल्यू लिखो. Right? So if you remember this expression तभी हो जाएगा. ये दोनों निकाल लोगे आप, ठीक है? नाउ अगर जेई के अंदर आपको कोई भी क्वेश्चन आ रहा है, सपोज वो कहते हैं हमको बताइए कि बामर सीरीज में व्हाट विल बी द रेशियो ऑफ द मैक्सिमम टू द मिनिमम वैल्यू. रेशियो भी लिख लो आप इसकी, लैम्डा मैक्स टू लैम्डा मिनिमम. हाउ मच इज इट? वैल्यू कितनी है? n plus 1 whole square upon 2n plus 1. परफेक्ट. अब आप देखो, सपोज वो कहता है लाइमन सीरीज का मेरे को ये रेशियो बताओ. fill in the blanks. n का वैल्यू क्या लेंगे आप इसके अंदर? What is the value of n you will take? n1. n1 का मतलब, लाइमन का मतलब n1 कितना हो गया? 1. कितना हो गया? 1 plus 1 कितना हुआ? 2 का स्क्वायर कितना हुआ? 2n plus 1 कितना हुआ? खत्म. आंसर. दिस इज अ मैजिकल रिजल्ट विच यू शुड रिमेंबर. डायरेक्ट वैल्यूज इसमें आ जाती है. अब सपोज पाशन की बात करते हैं. लेट्स टॉक अबाउट द पाशन सीरीज. निकालना जरा. ठीक है. नाउ लेट्स गो बैक टू द स्लाइड नंबर 19th. अब इस क्वेश्चन को करना. इसके नेक्स्ट 19th. आई सेड 19th. यस, करना है इसको. First slide means n2 1. I mean n2 next वाला. लाइमन का n2 कितना हो जाएगा? 2. बामर का n2 कितना हो जाएगा? 3. करो. कितना? What is the answer? Yes, the right answer is 5 by 27. Clear? Next slide. ये अब आप कर लोगे? ये तो हो गया. Next 21. Okay, have a look at this. Hydrogen, deuterium, singly ionized helium, and doubly ionized lithium all have 1 electrons around the nucleus. He says consider n equals 2 to n equals 1 transition. The wavelengths of the emitted radiations are lambda 1, lambda 2, lambda 3, lambda 4 respectively. Then approximately what their values are. अब इसको अटेम्प्ट कैसे करोगे आप? व्हाट इज डेल्टा इक्वल टू एच बाय लैम्डा? तेजस्विनी, एच बाय लैम्डा. अच्छा, और डेल्टा ई डायरेक्टली प्रोपोर्शनल टू जेड स्क्वायर होता है. दैट मींस एच बाय लैम्डा इज डायरेक्टली प्रोपोर्शनल टू जेड स्क्वायर. कैन आई से लैम्डा जेड स्क्वायर इज कांस्टेंट? अगर ट्रांजिशन कॉमन है सबके बीच में, तो कैन आई से लैम्डा इंटू जेड स्क्वायर इज कांस्टेंट? लिखो. सो इफ योर लैम्डा इंटू जेड स्क्वायर इज कांस्टेंट, फिर तो आंसर आ गया. इस तरह से माइंड को फास्ट करना है, जल्दी जल्दी चलाना है. दैट्स हाउ यू हैव टू वर्क. क्या आंसर आता है? आंसर ऑप्शन इज लैम्डा इंटू जेड स्क्वायर कांस्टेंट है. अच्छा एक बात बताओ, हाइड्रोजन और ड्यूटेरियम, इन दोनों में जेड की वैल्यू कितनी है? हाइड्रोजन, व्हाट इज हाइड्रोजन? H11. एंड व्हाट इज ड्यूटेरियम? पता है आपको क्या होता है? H21. ये होता है ना, दोनों में एटॉमिक नंबर सेम है. हाँ है ना? अब जरा चारों ऑप्शंस देखना. इन दीज फोर ऑप्शंस, which are the two options which have lambda same? A and D. So the answer is between A and D. Agreed? Now either it is A or it is D. Now tell me, if it is Z square, helium is Z equals 2, तो ये 4 होगा ना? तो कौन सा ऑप्शन हुआ? खत्म. करने का जरूरत नहीं है. डोंट हैव टू थिंक, डोंट हैव टू सॉल्व अगेन एंड अगेन. सिंपल चीजें हैं, बिल्कुल बिल्कुल सिंपल. व्हेन द ऑप्शंस आर गिवन, प्लीज हैव अ लुक एट द ऑप्शंस आल्सो. उसी में आंसर निकल जाता है कई बार. नेक्स्ट ऑप्शन, नेक्स्ट क्वेश्चन पढ़िए. Hydrogen atom in its ground state is excited by radiation of wavelength 975 angstroms. Now we're going the reverse way. We are saying that if you absorb so much, if the absorption is this much, what would be the emission, or how many lines of emission spectrum would be seen? ये क्वेश्चन ये है. करना जरा इसको. In the ground state, from the ground state, you get this much of wavelength. How many lines will be present? I'm not there, no? करिए. आप मुझे बताओ, 975 एम्स्ट्रॉन्ग्स लेने के बाद ये N1 से कहां जा रहा है? N2 क्या होगा? You have the formula. You know what is 1 by lambda equal to? कितना रहा N2? फोर, 3, 2, क्या रहा है? N2 4 आ रहा है, 3 आ रहा है. Okay. N2 comes out to be 4. ठीक है? Now tell me, if N2 is 4, how many spectral lines will be there? How do you find out? 10. formula is n into n minus 1 by 2. लिखना n into n minus 1 by 2. The number of spectral lines when electron from higher orbit falls to n equals 1. कितना होता है? n into n minus 1 by 2. कितना हुआ? 6. That's the right answer. C. 6 is the right answer. Great. 23rd. अब जो क्वेश्चन आपने अभी किया, देखिए सिमिलर क्वेश्चन नहीं है. Instead of the wavelength, he has given you energy. Similar question. We can solve it. Yes. So we'll leave it. Maths का option था तो this option is C. The correct option was C. So when you go back home, please do it again. Do it on your own. 24th. Do you know what is the wave number? 1 by lambda. इसको छोड़ सकते हैं, बाकी सब कुछ वही है. Similar question. Next. ये अच्छा सवाल है, करके दिखाना. 25th question. He says in a hydrogen-like atom, electron makes a transition from energy level with quantum number n to another quantum. The frequency of radiation is proportional to how much? ये करके दिखाइए. You have to tell me. जो रेडिएशन होगा उसका फ्रीक्वेंसी किसके प्रोपोर्शनल है? क्या रहा था? The first table I gave you, there was a relation between the frequency and the principal quantum number. देखना जरा. Just have a look at that expression again. क्या था? What was frequency dependent on? Absolutely. Inversely proportional to n cube. अब ट्राई करो. अच्छा एक बात बताओ, ये n वेरी वेरी लार्ज एज कंपेयर टू 1 का क्या सिग्निफिकेंस हुआ? जो डिफरेंस है वो ऑलमोस्ट नहीं समझे बात. He says if n is very very large, absolutely. So what will be the answer? B or C? क्यों? फ्रीक्वेंसी तुमने क्या लिखा अभी? इनवर्सली प्रोपोर्शनल टू 1 by n क्यूब. तो क्या होगा आंसर? 1 by n क्यूब. हाँ है ना? Yes. Next, 26th. Have a look at the question. 23rd question. A photon of energy 12.4 electron volts is completely absorbed by a hydrogen atom initially in the ground state so that it is in the excited state. The quantum number is. Now, what's his name? What is the boy's name? Okay. Now, please understand, beta, that when I've given you the energy of the photon, okay, now the energy of the atom in the ground state is minus 13.6 electron volts. Can I get that question back? 23rd, right. He says a photon of energy 12.4 electron volt is completely absorbed in the ground state. Now, in the ground state, the energy is minus 13.6 electron volts. I'm giving it an additional energy of 12.4 electron volts. So the total energy it has is minus 13.6 plus 12.4, which is minus 1.2. Now, if I have energy of 1.2 and my energy in this first level is 13.6, I can find out the value of n. That comes closer to option C, which is n equals 4. Okay. Next. तेजस्विनी, इससे पहले वाला क्वेश्चन लेना, इससे पहले प्रीवियस 25th, इस क्वेश्चन को दोबारा पढ़ो और फिर 26 पढ़ो और फिर मुझे बताओ कि 25th में आपने मिस्टेक क्या करी है. ये फ्रीक्वेंसी किसकी है? आप अपना वो चेक करो टेबल. एफ क्या था उसके अंदर, उस टेबल के अंदर? व्हाट वाज द एफ, व्हाट हाउ डिड यू डिफाइन एफ? क्या है ये फ्रीक्वेंसी? करेक्ट. और आपने क्या निकाला अभी? जब इलेक्ट्रॉन ट्रांजिट करता है तो वो किस फ्रीक्वेंसी की रेडिएशन एमिट करता है. तो दोनों अलग अलग चीज हैं. क्लियर? That means when you come back to this question number 25th again, please see what is he saying. In a hydrogen-like atom, electron makes transition from an energy level with quantum number n to another quantum number n minus 1. The frequency of radiation emitted. It is not the frequency with which electron is rotating around the nucleus. आप करके दिखाओ मुझको. How would you solve it now? This is frequency with which electron moves round the nucleus. And this frequency is the frequency of the emitted photon. Find out the difference and tell me the answer. Now tell me, Tejaswini, how is frequency of the emitted radiation dependent on n? Fantastic. Tejaswini is right. This frequency is directly proportional to 1 by n square. Right? Karo ab, solve karo. So what would I write? F is directly proportional to 1 minus n minus 1 square minus 1 by n square. Correct? I purposefully wanted you to get confused and you got confused. Are you clear now? Yes. What is the answer now? You have to take n greater than 1. So you can neglect the calculation. The correct option is D, 1 by n cube. Very good. 26. Right? Now, if you compare this question with question number 25, he says the frequency of revolution. Now, this is F naught, which is directly proportional to 1 by n cube. और जो इसका second part है, वो आपने अभी solve किया है. वो क्या relation आ रहा है? Proportional to 1 by n cube. Yes or no? So what is the right answer in this case? D is the right answer. Clear ba? So that was the significance to give you question number 25, followed by a question number 26, so that you can understand the difference between the two results. अब जल्दी जल्दी करते हैं जरा. 27th. Have a look at this. Fast track. Don't solve it. Tell me, can you do it or you can't do it? हो जाएगा. The shortest wavelength अभी किया आपने. Lambda minimum, lambda maximum निकाले है ना? Babel series हो जाएगा. आंसर क्या आ रहा है वैसे इसका? Great. Answer is B. 28th. चेक करो. किया आपने थोड़ी देर पहले सवाल ऐसा. लैम्डा का रिलेशन निकाला है. He is changing the values of z. Yes or no? Did we find out lambda z square is constant? Yes or no? Can we solve it? What should be your answer? बता दो सामने आपके. जब ये लिथियम की बात कर रहा है तो 9 तो आएगा ही ना. अगर ये लिथियम की बात कर रहा है तो 9 आएगा. 9 किस में आ रहा है? सी. तो क्यों सोच रहे हो इतना? चारों ऑप्शंस को भी देखा करो सॉल्व करते वक्त. क्लियर? नेक्स्ट स्लाइड. 30th. 29. अच्छा चेक करो. हो जाएगा ये. Wavelength of the first line of the Lyman series. The wavelength of the first line of the Lyman series 10 times ionized for 10 times ionized sodium atom is. Z कितना हुआ? Z कितना हुआ? 11 हुआ ना? If I say 10 times ionized, what does it mean? What will the value of atomic number? एक तो चाहिए ना आपको कम से कम. तो 10 बार आयोनाइज के तो Z का वैल्यू कितना होगा? 11 होगा ना? Yes or no? लिखो लिखो लिखो. इंपॉर्टेंट है ये. 10 times ionized atom. Students go wrong in this. They feel Z is 10 in this. Z is 11. And we know that wavelength is inversely proportional to Z square. Yes or no? Lambda Z square constant होता है, पता है हमको? That means the correct answer in this case is D. Perfect. Next, 30th. Check करो, जल्दी करो. Have a look at it. Have a look at it. You don't have to solve it. Just tell me, can you do it? Relation निकाल लेंगे आप? You know the relation of lambda? You know the relation of lambda? Can you find the relation of frequencies? मिल जाएगा ना? देखो, next, 31st. Check करो. An atom emits a spectral line of wavelength lambda when electron makes a transition from E1 to E2, which expression clearly relates lambda even in E2. Solve हो जाएगा ना? It's a simple relation. हाँ है ना? हो जाएगा. 32nd. Check करो. A stationary hydrogen atom of mass m emits a photon corresponding to the first line of Lyman series. We can solve it. So I have with me a lot of questions, but we have a limitation of time. I'm going to discuss, since these questions remain with you, right? I think you send them now. All these questions are sent to them. Perfect, huh? Fantastic. You have these questions. You know the concept now. One important concept which I want to discuss was very, very important is likho, atomic collisions. Atomic collisions. ठीक है. Okay. एक क्वेश्चन लिखिए आप पहले. There are two atoms, or there are two particles. Say this is a neutron. It has a certain kinetic energy and a certain velocity v. This is a hydrogen atom. At rest. Perfect. Now, the question is, if the kinetic energy of this neutron is the values 14 electron volts, 20.4 electron volts, 22 electron volts, or 24.18 electron volts, 4 cases, he's asking you what would be the nature of collision in all the 4 cases. Now, when I say nature, I am saying pure elastic, I am saying inelastic, and I am saying pure inelastic. Let's understand this. Okay? Now, tell me kids one thing, girls. एक न्यूट्रॉन है, वो हाइड्रोजन एटम को कोलाइड करता है, ठीक, इतनी एनर्जी के साथ आता है. अब if neutron has to hit a hydrogen particle, if it does not lose energy, that's one case, pure elastic collision. It loses all its energy, pure inelastic. Incorrect. That is one concept which students wrongly understand. Let's first understand, do you agree they have same mass? Tell me one thing, if there are 2 particles, one at rest, the other same mass, traveling velocity v, what is the maximum loss of kinetic take place? Let's find out. I'll give you a beautiful result. Isko yaad karo. Loss in kinetic energy is equal to, kitna hota hai? Anybody knows this? Half mu v relative whole square. इसके आगे ये भी होता है 1 minus e square. Now for pure elastic collision, okay, E is 1, delta K E becomes 0. For pure inelastic collision, E becomes 0. Your delta E or delta KE becomes half mu V relative whole square. Okay? Now in this case, mass is also same. Now this mu is basically reduced mass. It's m1 m2 upon m1 plus m2. If both the masses are same, mu की value कितनी हो जाएगी? m square by 2m, m by 2. ये कितना आता है? Half m by 2. Now v relative is the velocity of one with respect to the other. Second तो rest पर ही है, तो ये कितना हो गया? अच्छा by the way, ये क्या है? K naught. If I take this as K naught, तो भाई साहब loss कितना हुआ? If there are 2 particles, interesting, very interesting in mechanics and in atomic physics, the maximum loss which a particle can undergo if it collides with another mass, similar mass at rest, is max is K naught by 2. ठीक है? Now, ये न्यूट्रॉन है, ये हाइड्रोजन एटम है. अगर प्योर इलास्टिक कोलिजन होती है तो जो लॉस होगा वो 0 होगा. दिस गोज फॉर इलास्टिक, प्योर इलास्टिक. अगर प्योर इलास्टिक होगा k naught by 2 होगा. This will be pure inelastic collision. लिख ही देता हूं इससे अच्छा. प्योर इलास्टिक, प्योर इलास्टिक कोलिजन. परफेक्ट. अब जरा पहला केस देखते हैं. अच्छा, ये कोलिजन हो इसके लिए लाए so that when atoms hit each other they can transit to the next level. नेक्स्ट लेवल के लिए एनर्जी लेवल्स क्या है? व्हाट इज द एनर्जी डिफरेंस यू नीड? डेल्टा ई बताना. बोलो बोलो. पॉसिबल एनर्जी लेवल्स कितने होंगे? इट डजंट ट्रांजिट जीरो. फर्स्ट ट्रांजिशन -13.6. व्हाट इज सेकंड? 3.4. डिफरेंस 10.2. यस और नो? तेजस्वनी समझ में आ रहा है तेरे को? 1 से 2 में ट्रांजिट करने के लिए ये एनर्जी डिफरेंस चाहिए ना. 1 से 3 में ट्रांजिट करने के लिए कितना एनर्जी डिफरेंस चाहिए? ये लिख लो आप अप्रोक्सीमेटली. फोर्थ भी लिख लेते हैं. चलो, फाइनल कितना चाहिए? ठीक है, लेट्स कम बैक हियर. ये कितना एनर्जी है? 14. ठीक. आइदर इट डजंट गिव एनी एनर्जी, it stays in the first orbit, it remains the pure elastic collision, और मैक्सिमम कितनी दे सकता है ये? इसका आधा. वो कितना हुआ? और मिनिमम चाहिए कितना? तो इसका मतलब इनइलास्टिक कोलिजन, प्योर इलास्टिक कोलिजन नहीं हो सकता. प्योर इलास्टिक कोलिजन हो सकता है. लिखो 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 लिखो. Interesting now? It's an interesting thought. Okay. Right, girls? अब इसके बारे में बात करते हैं. It doesn't lose any energy. Can remain in the first orbit. Pure elastic is possible. इसका हाफ कितना हुआ? Possible. That means a pure inelastic collision is also possible. ठीक. What about this? ये कितना हुआ? क्या मतलब हुआ? What is the maximum loss it can undergo? 11. चाहिए कितना? क्या मतलब हुआ इसका? पॉसिबल है? Is this transition possible? सोच के बताओ. Take your time. And then tell me about this also. Think. We're not in a hurry. अच्छा, अगर ये परफेक्टली इनइलास्टिक कोलिजन होता तो ये केस होता ना. अगर ये केस है तो इसका मतलब परफेक्ट इनइलास्टिक कोलिजन नहीं होगा. इनइलास्टिक कोलिजन तो होगा. ठीक है ना? That means in this case either it will be perfectly elastic or it will be inelastic, not perfectly inelastic. Note करो. फोर्थ केस बता दो. ये कितना होगा? $12.09 हाफ. So, and perfect. There is one more concept which I want to tell you. Again, very important for your entrance exam. You know, we say that there is a hydrogen atom. Right? Say it releases a photon. They can ask you, what is the recoil speed of the hydrogen atom? What is the recoil speed of the hydrogen atom? Okay. Do you agree that the linear momentum of the system has to remain conserved? Do you agree? अब एक फोटोन जब बाहर आएगा तो मोमेंटम कितना लेके आएगा? h by lambda. If mass of the hydrogen atom is m and velocity is v, can I say mv will be h by lambda? लिखो. ठीक है? Perfect. Now suppose I say, तो v के वैल्यू कितना आ गया? लैम्डा गिवन होगा आपको, मास ऑफ हाइड्रोजन एटम नोन, प्लैंक्स कांस्टेंट, और इस तरह से आप इसको सॉल्व कर सकते हैं. ठीक है? ओके. नाउ लेट्स गो ऑन टू न्यूक्लियर फिजिक्स. स्लाइड्स लगाना जरा. बाइंडिंग एनर्जी कर्व, डायरेक्टली हम इस पे आते हैं. इससे पहले मैं आपको, डू यू नो व्हाट इज बाइंडिंग एनर्जी बाय द वे? पता है आपको? एक न्यूक्लियस की बाइंडिंग एनर्जी होती है, एक रिएक्शन का बाइंडिंग एनर्जी होता है. यू नो व्हाट इज बाइंडिंग एनर्जी ऑफ अ न्यूक्लियस? लिखो. Suppose I take a nucleus is equal to number of neutrons, protons, या neutrons ले लेते हैं, plus minus is this fine? This is the binding energy of a nucleus. ठीक है ना? Clear? Second thing in which this is the stability graph. बनाओ. You know, if I take the number of neutrons here and number of protons here, the curve goes like this, and after some time it bends like this. लिखो. This value is A equals 40. We say here n is equal to P and here n is greater than P. Now, inside a nucleus, there are many forces which are operating, but there are two primary forces. One is a nuclear force, which is a short range force. B, a very strong force. D, attractive. E, independent of charge. Also, you have Coulombian force. Charge dependent. Inside the nucleus, you have protons and neutrons. Protons have a positive charge. So there can be a strong Coulombian repulsion. Now, if you see this graph very carefully, there are certain important points I want to tell you. The binding energy graph. इसको बहुत seriously लोग लेते नहीं है, इसको थोड़ा seriously देखते हैं. Do you realize that when the mass number is low, it suddenly rises? What do you mean by binding energy per nucleon? समझो बात को. There is a nucleus. There are protons and there are neutrons. As far as nuclear forces are concerned, it doesn't bother whether they are positive or they're neutral. They are independent bodies which can attract each other. अब problem क्या होता है? One nucleon is surrounded by other nucleons. अब एक न्यूक्लियन, ध्यान सुनना, के साथ एक दूसरा न्यूक्लियन आया. Now binding energy per nucleon means this single nucleon, how much close or what is the force which this attractive force which this nucleon applies on this nucleon. अब शुरू में क्या होता है, जैसे जैसे न्यूक्लियन ऐड होते चले जा रहे हैं, बाइंडिंग एनर्जी या स्टेबिलिटी बढ़ते जा रही है. अट्रैक्शन, सब मोर द अट्रैक्शन मोर द स्टेबल. जितना सिस्टम रिपल्सिव होगा उतना वो अनस्टेबल होगा. So that means when I have a single nucleon, now binding energy per nucleon means एक न्यूक्लियन के साथ एक आया, फिर दूसरा आया. तो शुरू में जब मास नंबर कम होता है, कम न्यूक्लियंस होते हैं, this increases very fast. Then what happens? Now अब क्या हुआ? This is one nucleon. एक एक न्यूक्लियन यहां पर सेट हो गया. There is an effect called saturation effect. After some times, when the second layer has to come, now this nucleon of the second layer is not attracted to this nucleon. That means after a certain time, when you keep adding the nucleons, the binding energy of this single nucleon is not going to change. So that means in this period, this surge is because every single nucleon is getting attracted by one single nucleon. But in this stage, in this period, because of the saturation effect, the change in binding energy per nucleon, it does not increase, it doesn't change. Okay. अब आप देखो इसका थर्ड पार्ट. अब ये फॉल क्यों हो रहा है? Two forces, attractive, Coulombian. Nuclear forces are short range forces. तो जब एक सिंगल न्यूक्लियन के पास दूसरा न्यूक्लियन आया, अफेक्ट ज्यादा आया. Coulombian forces are long range forces. अब जब बहुत सारे न्यूक्लियंस हो जाएंगे, तब Coulombian force will come in play. अब रिपल्शन का इफेक्ट भी आएगा. But since nuclear forces are very strong, as compared to Coulombian forces of repulsion, the effect of nuclear attraction is more than Coulombian repulsion. So there is a fall, but the fall is not steep. It is gradual. Now, since you girls are not left with time, what we'll do is, maybe I'll have to take one more session, or we'll have to do something about it. I'll be needing 1.5 hours more. या फिर what I can do is I can give you these notes. I can give it to you. I'll give you the questions. You can go through them. एक बार जरा slide change करना वैसे. Next slide. Next. Try करोगे इसको? Can you do that? Can you do it? Momentum conservation. Yes. एक मैं बहुत जल्दी से, I'll just take 5 minutes. I'll give you some basic formulae which you ought to remember. लिखो फटाफट. In the next 5 minutes, I'll give you the formula. First of all, there is something called the Q energy. Let's understand. Q energy comes, these questions come under the category of nuclear reactions. Like for example, there is kinetic energy of the, I represents incident particle, okay? Capital I is the incident particle. Now, you do agree in nuclear physics, mass also is energy and kinetic energy is also energy. So whenever we talk about energy expressions, we have mass as well as its kinetic energy. तो ये भी एक energy का source है. I represents the incident particle. This is kinetic energy of the incident particle. They form a product. P is product. O, then you can say Kp is the kinetic energy of the product. T is the target. Okay. I'll also have a O and a KO. Incident becomes P. Okay. Target becomes O. Outcome लिख सकते हो आप इसको. Now, Q is basically, ध्यान से देखना, is Kp plus Ko minus Ki. ठीक. This can also be written as, ये है किसके बराबर? Mass of incident particle, mass of target minus mass of product plus mass come into C square. This is called Q value. ठीक है. If Q is positive, it is called exothermic reaction. ठीक है. Okay. Now, if Q is negative, if Q becomes negative, इसका मतलब ये हुआ that you need to have a threshold value of energy or threshold energy to initiate a process. ठीक. The value of threshold energy, वो भी लिख लीजिए आप. K threshold is M plus M by capital M into mod of Q. I'm using a mod Q because Q will be negative, so I need the mod value. This is the threshold value. Okay. इस expression में Q का value है वो भी लिख लीजिए. is K naught minus Ki ठीक. This energy is in the ground frame. Three more minutes. मेन प्रोसेसेस होते हैं, एक होता है अल्फा डीके. फटाफट लिखो. इसका प्रोसेस इक्वेशन लिख देता हूं मैं. ठीक लिख रहा हूं. 4 2 के अल्फा प्लस के वाई. Spontaneous process. A nuclei disintegrates into a product. Okay, product is Y. इसमें if I have to find the value of K alpha, this is A minus 4 by A into Q. Your KY is 4 by A into Q. ये values याद कर लेना. K is kinetic energy of the alpha particle. Okay, and Y kinetic energy of the residual. Q का वैल्यू लिख लीजिए. Will be mx minus my minus m alpha इसका मास into c square. फिर आता है बीटा नेगेटिव डीके. I'll write the process equation for you. Proton, or you can say it's a parent. A parent disintegrates into a daughter. It comes out with an anti-neutrino also. ठीक है, इसका Q वैल्यू लिख लीजिए. दो इक्वेशन और रह गई. बीटा प्लस डी के पेरेंट डॉटर positron and a neutrino. This is a neutrino. इसका Q वैल्यू होता है, वो भी लिख लो आप. MP minus MD minus 2 times mass of the electron into C square. And finally, electron capture. Parent, it captures its all orbital, अपने ही इलेक्ट्रॉन को ये कैप्चर कर लेता है. डॉटर एंड अ न्यूट्रिनो. इसका Q वैल्यू आता है we could somehow manage it. ठीक है, the questions you will get from my slides, you will get those slides, see them, and all the best. We could finally complete this also. Thank you.
Let's start with the electrochemistry. In electrochemistry, there are three different things. One is electrolysis, other is electrochemical cell, and last one is conductance. So we'll start with electrolysis. What is the difference between electrolysis, electrochemical cell, and conductance? When you use current electricity to convert a chemical reaction or to do a chemical reaction, we use current electricity. This method is known as electrolysis. If you produce electricity with the help of chemical reaction, this is known as electrochemical cell. So let us take an example of a redox reaction in which A plus B is converted to A plus and B. So this is a redox reaction. So with the help of current electricity, if this redox reaction is take place, this process is known as electrolysis. This process is known as electrolysis. So why we are going to use current electricity to do a chemical reaction? Actually, there are infinite number of chemical reactions which cannot be take place when you react A and B. But with the help of current electricity, the reaction can take place. Let us take example of sodium chloride. Now, in sodium chloride, Na is in the plus form, Cl is the minus form, molten sodium chloride. It might possible chlorine loss electron and it is converted to Cl2. And the loss electron is accepted by this Na plus and it is converted to Na solid. But practically, is this reaction is possible to prepare chlorine gas from sodium chloride? No. So there are infinite number of reactions which are not possible in the normal uses conditions. But if you take sodium chloride in molten form, sodium chloride in molten form and connected through a battery, now in this case, the above reaction which is not possible in the normal condition can easily take place in application of current electricity. So what is the use of electrolysis? There are different type of reaction which are unable to proceed, but in the presence of current electricity, such reaction take place. So this is the main use of electrolysis. Is it clear? Now, for the calculation part, we use different law of electrolysis. First is Faraday law of electrolysis. Consider a container having water. In this container, we have dipped 2 electrodes and it is connected with the help of battery. This is positively charged, this is negatively charged. When both the electrodes are connected with the opposite end. Now, after connecting this battery with the positive end, this entire electrode is positively charged and this entire electron is negatively charged. Assuming that this is water consists of electrolyte AB, where charge of A is positive, charge of B is negative. So I am talking about a chemical reaction or a solution which consists of electrolyte A plus and B minus, and this solution is connected with 2 electrodes. Both the electrodes are attached with a battery having charge positive and negative. Now, due to this positive charge, the negative ion will be attracted towards this pole and positive towards negative. So B minus in the positive part, B minus lost 1 electron and converted to B solid, maybe possible B aqueous, plus electron. Loss of electron is known as oxidation. Loss of electron is known as oxidation. That means B losses electron and this process is known as oxidation. Oxidation take place in the positive part. Therefore, this is what we call anode. Anode and cathode are not distinguished by charge plus or minus. It is mainly identified by oxidation or reduction. If oxidation take place, it is known as anode, irrespective of charge. It might possible, it may be negative, it may be positive, but if oxidation take place, it is anode. So in anode, B minus lost one electron to form B solid, whereas in cathode, A plus accept this electron and convert it to A solid. Is it clear? B minus losses one electron, oxidation, therefore anode. A plus accept this electron to convert it to A solid. This is cathode. So this is the basic reaction of anode and cathode. Now, what is the use of this battery? This battery create a potential for these two electrodes, plus and minus. It is not the source of electron. That means the electron which is accepted by A plus is same which is donated by this B minus. If B minus lost 10 electron, A plus will accept 10 electron. It is not possible that battery will give or produce some extra electron to the solution or system. That means we can able to say equivalent of B is always equals to equivalent of A. Equivalent of B is always equals to equivalent of A. Why? Because the number of electron loss in anode must be equal to number of electron gain at cathode. Therefore, if it lost 10 electron, it must gain 10 electron. If the charge is -1 and +1, that means moles of B form in the first reaction is equals to moles of A form in the second reaction. But in all case, we cannot able to say that moles are equal, because the charge, if this is the oxidation state of this A plus is 2 plus, then it accepts 2 electron. In that case, we have to take equivalent. So in all cases, irrespective of their charges, we can able to say that the equivalent of product form in anode is always equal to equivalent of product form in cathode. Clear? Maximum numerical can be solved by this equation. Is it clear? Now, let us assume that we are calculating the amount of A which is deposited in this cathode. Can I say weight of A deposited is directly proportional to Q? Weight of A or weight of any electrolyte deposited in anode or cathode is directly proportional to Q. Why this is? Because if let's say I have added 10 electron to anode, that means 10 moles of A will be deposited. If we'll add 100 electron to anode, 100 electron will be deposited. That means weight of any electrolyte deposited must be equal to, must be proportional to Q. Now, if proportional is converted to equal, that can be written as Q into Z. Is it clear? How you define Q? Q is total number of charge. For example, if I take 1 mole of electron, if I take 1 mole of electron, can I say 1 mole of electron means 6.023 multiplied by 10 to the power 23? What is the total charge of 1 electron, 1 mole of electron? 6.023 into 10 to the power 23 multiplied by charge of 1 electron, that is 1.6 into 10 to the power minus 19. If you multiply both the factor, you will get 96500 coulomb. This is charge of 1 mole of electron. Can be written as 1 Faraday. Can be written as 1 Faraday. Can I say if I added 1 coulomb of 96500 coulomb of charge, that means I have added 6.023 into 10 to the power 23 moles of electron. 6.023 10 to the power 23 electrons. Now, if I add 6.023 into 10 to the power 23 electron in A positive, or in this A minus, that means this much electron, 96500 or 1 mole of electron will deposit equivalent weight of that particular solid. Why I have written equivalent weight? Let us take an example of 2 salt, A plus and B2 plus. The atomic number of A plus is 10. The atomic number of B plus is also 10. What is 10? This is atomic weight of A and B. Now, if I add 96500 coulomb of electricity, that means I have added 1 mole of electron. If I add 1 mole of electron, A plus will deposit 1 mole because 1 A plus required 1 electron. 1 mole of A plus required 1 mole of electron. That means if I add 96500, this much coulomb of electricity, it will produce 10 gram of A. But if the same charge is passed for B, now 1 mole of B required 2 moles of electron. From this number of electron, that means 1 mole of electron, moles of B deposited must be half. But if I will write 96500 coulomb deposit equivalent weight of weight, in such cases, if I add equivalent weight of B, it is 10 by 2 equal to 5. Equivalent of A, it is 10 by 1 equals to 10. So it is valid for both these cases. So I can able to say, if I add 96500 coulomb of electricity, the weight deposited equal to equivalent weight. Now for 1 coulomb of electricity, the weight deposited must be equal to E by 96500. Clear? So what is E by 96500? It is when 1 coulomb of electricity is passed, the weight of any electrolyte deposited at cathode or anode. Now, I have written W equals to Z into Q. How you define Z? Can I say when the value of Q is 1, the value of Z equals to W? Now, if I write value of Q equals to 1, that means when 1 coulomb of electricity is passed, the weight of electrolyte deposited equals to Z. Now, when 1 coulomb of electricity passed, the weight of salt deposited at anode is E by 96500. So this equation can be rewrite as W can be written as EQ upon 96500. Clear? So can I say weight of any electrolyte deposited is equals to equivalent weight of that particular electrolyte multiplied by Q divided by 96500. Q can be written as I into T. What is I? Current. Time in seconds divided by 96500. So this is what we called weight of any electrolyte deposited. So this equation can be rewrite as W by E Q W by E equal to Q upon 96500. What is W by E? This is what we call equivalent. So equivalent of any electrolyte deposited at cathode or anode is always equals to Q by 96500. Q is the quantity of electricity passed through the solution. Clear? Clear? Now, let us take an example of molten sodium chloride. Molten sodium chloride. There are solutions which consist of more than one ion. There are solutions which consist of more than one ion. Then the ion which have higher discharge potential will discharge first. What is discharge potential? Let's say B minus. There are two anion, B minus and A minus. If B minus give one electron, this is what we call oxidation of B. This is called oxidation of A. If the oxidation potential of B is 5 volt, oxidation of A is 4 volt. The oxidation of B is higher than the oxidation of A, then B will be discharged. But in the numerical or in the objective question of electrolysis, the oxidation potential is not given. So in some common salt, we have to memorize the oxidation potential. Now, take an example of molten sodium chloride. Molten sodium chloride. And we have given 2 electrolyte of platinum connected with a battery. In molten sodium chloride, there are only 2 ions. One is Na plus, other is Cl minus. So there is no confusion in anode as well as cathode. The anode oxidation, chlorine Cl minus will be produced, and the electron at cathode is absorbed by sodium Na plus. to give sodium solid. Let us take another example of same sodium chloride. Now, I have added sodium chloride in a container which consists of water. This is what we call aqueous sodium chloride. Aqueous sodium chloride, and this sodium chloride is concentrated. This sodium chloride is concentrated. Now, in this case, there are 4 ions. One is H plus, other is Na plus, second is Cl minus and OH minus. So in anode, now there is a competition between Cl minus and OH minus, which get discharged. So if I remember the oxidation potential of Cl and OH minus, it is mainly depend upon the concentration of the ion also. If you take higher concentration of chlorine, the OH minus must be present 10 to the power minus 7. If you take the higher concentration of chlorine, Cl minus, if you increase the Cl minus concentration, the oxidation potential will be higher than OH minus. In that case, chlorine get discharged at anode, and the reaction will be 2Cl minus gives Cl2 plus 2 electron, whereas in cathode, H plus accept 2 electron to form H2. Between H plus and Na plus, that is alkali metal, or between H plus or alkali earth metal, always H plus get discharged over there. Is it clear? Now, let us take another example of same sodium chloride. Same sodium chloride. In this case, I have taken sodium chloride in the dilute form. In the dilute form. As I have told you that between the Cl minus and OH minus, the discharge potential of OH minus is higher. But if I take higher concentration of Cl minus, the discharge potential of Cl minus will be higher. Now, if I take NaCl in the dilute form, the oxidation potential of Cl minus and OH minus, which will be higher? OH minus. So, in anode, the reaction is 4OH minus will give you oxygen plus 2 H2O plus 4 electron. Is it clear? 4O2. I have balanced the reaction. 2 oxygen, 4, 4H, 4H, 4 electron. In this case, 4OH minus produce 1 mole of oxygen, 2 mole of water and 4 electron. Whereas in the cathode, the hydrogen accept 2 electron to give H2. I have to balance the reaction, so multiply this equation by 2. Therefore, it is 4. Now the electrons are balanced and 2 moles of hydrogen will be produced. Take another example of sodium chloride. But in this case, all cases 1, 2, 3, I have taken platinum as an electrode. But in case 4, we have taken mercury as an electrode. If you take mercury electrode, in anode, the oxidation of chlorine minus take place. Whereas in cathode, the oxidation of sodium take place. Sorry, reduction of sodium take place. That is, what will be the change? Instead of H plus ions, Na plus get discharged or accept electron. Why this happen? Because in the mercury electrode, sodium react with mercury to form sodium mercury amalgam, which is exothermic reaction, and delta G get negative charge. So in delta G, if delta G is negative, the reaction is spontaneous. Therefore, sodium mercury amalgam form. Is it clear? So these are the 4 different cases. I have taken the same salt, sodium chloride, and same salt, sodium chloride undergo different type of process as well as different type of reaction. Clear? So in electrolysis, the questions or the numerical asked, there are 2 type of rotation. One is to identify the reaction as well as anode and cathode. Then you put the current, electricity as well as the equivalent part. Is it clear? For example, a very simple question. If 10 to the power minus 1 molar, 10 to the power minus 1 molar H2SO4 is electrolyzed, by 10 ampere current for 10 seconds. If 10 to the power minus 1 molar sulfuric acid is electrolyzed by 10 ampere current for 10 seconds, calculate total number of moles of gas produced after complete electrolysis. After complete electrolysis. Before solving any numerical, write down the reaction of anode as well as cathode. After writing anode and cathode reaction, then apply the current as well as time to calculate the equivalent. Always remember the equivalent of any salt produced at anode as well as cathode are always equal. In this numerical, do we require equations in anode? Oxidation, OH minus, O2 plus H2O plus 4 electron. Is it clear? Always remember the discharge potential or the reaction between SO4 and OH minus get reacted. Whereas in cathode, 2H plus 2 electron give rise to H2. Now, how to solve this numerical? First of all, you have to calculate W by E can be written as IT by 96500. What is the value of I? 10 times 10 upon 96500. That means equivalent is 1 by 965. Equivalent is 1 by 965. Can I say equivalent of O2 produced equals to equivalent of hydrogen equals to 1 upon 965? Clear? Now, total moles of gas produced must be equals to moles of O2 plus moles of H2. Now, moles of O2, 1 by 965 is the equivalent of O2. What is the N factor of O2? 4. How you define N factor? Number of electron gain or loss to form one molecule of O2. If you see one molecule of O2, we require 4 electrons. That means the N factor of O2 is 4. If the moles of O2, equivalent of O2 is 1 by 9650 divided by 4 is the moles of O2. What is the moles of hydrogen? The N factor is 2. So the answer will be 1 by 965 multiplied by 4 plus 1 by 965 into 2. So this is the moles of O2. This is moles of H2 produced. So the total number of moles is this plus this. Is it clear? Clear? Okay. One more question. Assuming that we have a solution which consists of sodium acetate in aqueous medium and it is tight electrolyzed again by 10 ampere current for 10 seconds. I am repeating the question. I have sodium acetate, aqueous sodium acetate, and it is titrated by 10 ampere of current for 10 seconds. You have to calculate the total number of moles of gas produced after reaction. First, write down the reaction of anode and cathode. After writing anode and cathode, just calculate the equivalent of gases formed at anode or cathode. Then convert that equivalent to mole. What is the reaction of anode and cathode? What is the reaction of anode and cathode? Anode, oxidation. Can you able to recognize this reaction is basically Kolbe's electrolytic method? So can I say at anode CH3C double bond O minus, it donate a pair, sorry, it donate a single electron and convert it to O radical. We know O radical is highly unstable. Can I say two molecule, two, and this is two electron? O radical is highly unstable and formation of carbon dioxide is an exothermic reaction. So this O radical again produce two methyl radical plus carbon dioxide. Now we know that the methyl radical are again highly unstable and they combine to form ethane. So this is basically Kolbe's electrolytic method, and the main drawback of Kolbe's electrolytic method is the formation of this free radical. It might possible this free radical may rearrange or combine with this O radical to form esters. So this is the major drawback of Kolbe's electrolytic method. Now in cathode, the electron which are released is absorbed by two hydrogen to form H2 gas. Therefore, we are saying that in Kolbe's electrolytic method, as the reaction proceeded, the pH of solution increases because H plus is converted to H2 gas. Now, if I write down the entire anode and cathode reaction, can I say at anode, two equivalent of acetate ion combine to form one ethane gas, two carbon dioxide and release two electron, whereas in cathode, two hydrogen accept two electron to form H2. Is it clear? Now, let us calculate the equivalent. Equivalent can be written as EQ is 1 by 965, 10 into 10 multiplied by 96500. If the equivalent is this much, can I say total number of equivalent of gas, equivalent of ethane must be equals to, equivalent of ethane must be equal to equivalent of carbon dioxide and equivalent of H2. Clear? So I can able to say that total equivalent of gas produced, total equivalent of gas produced is equals to equivalent of ethane plus equivalent of CO2 plus equivalent of hydrogen. Now, what is the equivalent of C2H6? This is 1 upon 965. How to calculate the mole? You can able to see that to prepare 1 mole of ethane, we require 2 moles of electron. Therefore, the N factor of ethane is 2. So divide this 2 to this equivalent. Now, this is the moles of ethane. Again, in carbon dioxide, you can say 9650. To prepare 2 moles of carbon dioxide, 2 electrons are released. So the N factor of carbon dioxide must be 1. So equivalent equals to moles. So I have written 1 by 965. What is the N factor of hydrogen? It is 2. So you can able to write 1 by 965 multiplied by 2. So this is the total number of moles of gas produced after reaction. Is it clear? Is it clear? So now you can able to solve all the questions related to Faraday's first law. According to Faraday's second law, the equivalent of any solid form at anode is always equals to cathode. Respectively, in the parallel reaction, all equivalents are same. Clear? So one more question for electrolysis. PPT. PPT. An acidic solution of Cu2 plus salt contains 0.4 gram of Cu2 plus is electrolyzed until all copper is deposited. The electrolysis is continued for 7 more minutes. With the volume of solution kept at 100 ml, the current is 1.2 ampere. Calculate the volume of gas evolved at NTP during the entire electrolysis. NTP and STP both are same. Let's see the solution. See, there are in the question there are two type of container. One, this solution or this container consists of H plus, OH minus, Cu2 plus. Cu2 plus is 0.4 and the current is 1.2 ampere. Is it clear? When this solution is electrolyzed, there are two cation. One is H positive, other is Cu2 plus. Which cation will get deposited? Cu2 plus. Now, if I say at anode oxidation, OH minus gives O2, 2H2O and 4 electron, whereas in cathode, Cu2 plus accept 2 electron to give copper solid. Now in the question it is given that this electrolysis is continued till all copper is deposited. That means if the molarity of this Cu2 plus is 0.4 and the volume I think 100 ml is mentioned, solution kept at 100 ml. So millimole of Cu2 plus present in this solution must be equal to 0.4 into 100. Millimole divided by 1000 is moles. 0.04. Now the N factor of Cu copper is 2. Can I say equivalent of copper can be written as equivalent of O2 produced in the above reaction? And equivalent of copper produced in this reaction is 0.04 multiplied by 2, that is equivalent of O2. Why I have multiplied 2? Because to prepare one Cu, we have it accept 2 electrons. Is it clear? Now, after this reaction, the electrolysis again continue for 7 more minutes. If I say after 7 minutes, this container consists of 2 ion, now H plus and OH minus. Copper is completely consumed. Therefore, the reaction must be like this. 4 OH minus gives O2 plus 2 H2O plus 4 electron. Whereas at cathode, instead of Cu2 plus, now H plus will be discharged. It accepts 2 electron to give H2. Can I say equivalent at this point of time is 1.2 ampere current for 7 minutes? For 7 minutes multiplied by 60 seconds divided by 96500. So this is the equivalent of oxygen produced. This is the equivalent of hydrogen produced. Now can I say total moles of gas is mole of hydrogen produced in the first stage plus mole of oxygen produced in the first stage plus mole of oxygen produced in the second stage. So I can able to say total equivalent of gas produced are equivalent of oxygen in first, equivalent of oxygen in second, equivalent of hydrogen in second stage. Equivalent of oxygen produced in the first stage is 0.04 into 2. Equivalent of oxygen produced in the second case is 1.2 multiplied by 7 multiplied by 60 divided by 96500 plus equivalent of hydrogen produced 2 multiplied by 7 into 60 by 96500. Is it clear? So this is the total equivalent of gas produced after electrolysis of 7 minutes. If you calculate the moles, divide this equivalent of oxygen by 4, divide this equivalent of hydrogen by 2. Total mole number of moles of gas produced will be calculated. Is it clear? So now let us consider some example of galvanic and electrochemical cell. Galvanic or electrochemical cell. So how you define galvanic or electrochemical cell or battery? Almost all batteries are one kind of electrochemical cell. So why we are going to use battery? To produce current electricity. The mobile battery, the pencil battery, all battery are one kind of electrochemical cell. So before start, let us consider a redox reaction. Copper plus zinc give rise to copper solid plus Zn2 plus. How you define current electricity? If any from any external circuit flow of electron take place, we used to say that electricity is produced. So let us consider this basic chemical equation. In this reaction, copper from plus 2 goes to copper solid, and this Zn from 0 to Zn2 plus. Can I say in this reaction, Cu2 plus accept 2 electron to give copper solid, whereas Zn lost 2 electron to give Zn2 plus? Is it clear? So this is a perfect redox reaction. So if I want to produce electricity, what I required is let this reaction continue, but the gain and loss of electron take place through some external circuit. That means this copper accept these 2 electron, this zinc losses 2 electron, but the loss of these 2 electron will be through external circuit to this copper. So flow of electron through external circuit is known as current electricity. So we have to prepare certain cell such that the loss and gain of electron will take place through external wire. Now, you will say that if electricity is produced, so we are converting work done to chemical reaction, work done of a chemical reaction to current electricity. So the energy of this system must be decreased. So which energy is available to convert this chemical reaction into electrical energy? That energy is known as Gibbs free energy. So how you define Gibbs free energy? Let us take this same example, and in the same example, we know every reaction is present in an equilibrium. So let's say this is the equilibrium. This is a equilibrium, and the concentration of Cu2 plus is 0. Copper zinc solid I have taken 10 moles, and the volume of this container is 1 liter. And the volume of the container is 1 liter. What is the concentration of Zn2 plus? It is 0. What is the concentration of Cu2 plus? It is 10. Now, what is the value of Qc? It is approximately 0, 0 by 1, 10. Now, let us take an example. The value of Kc is 10. The value of this equilibrium is 10. I am taking, let's say it is 10. I don't know the exact value of Kc. If I taken 10 mole of Cu2 plus 0 and Qc is approximately equal to 0, this reaction goes which direction? Forward direction. Now, in this case, when the Qc is less than Kc, in this case, when the Qc is less than Kc, the delta G must be negative, let's say minus 500 joule. Is it clear? And we know that if Gibbs free energy is negative, delta G is negative, the reaction must be 100% spontaneous. So the direction of this reaction is forward. Till we get 10 mole of Zn2 plus and 1 mole of Cu2 plus. 10 mole of Zn2 plus and 1 mole of Cu2 plus. At this stage, if you calculate, the value of Qc now equals to Kc and the value of delta G is 0. Is it clear? So can I say to 0 when I have prepared this cell with 11 moles of Cu2 plus in 1 liter of container, 10 mole of Zn solid, the value of copper solid and Zn2 plus must be equal to 0. Qc is less than Kc and the free energy is minus 500. Now this reaction is spontaneous, goes to forward direction till the equilibrium is reached, and we have assumed that the Kc value is 10. When the concentration of Zn2 plus is 10, concentration of Cu2 plus is 1, the value reaches to Kc and the delta G is equals to 0. Now see the initial delta G, it is 500. See the equilibrium delta G, it is 0. So the amount of energy which is converted to electrical energy is 500. That means if I am using this redox reaction to prepare a battery to produce current electricity, I have available energy 500 joule. This 500 joule, this 500 joule of energy is converted to electrical energy. Is it clear? Now we will deal with the structure of a galvanic cell, how to prepare a galvanic cell. Clear? Now, if you see this concept, so it is very easy to prepare a galvanic cell. There are ion who want to accept the electron. There are ion which donate to electron. If I tell like this, take a solution of Cu2 plus having 11 molar concentration, dip a zinc solid in this. This is zinc solid. Now, put a wire connected with a bulb and this solution. Now, what I want to see that this Zn converted to Zn2 plus, 2 electron in this point, they travel, this bulb will glow, and from this point, Cu2 plus will accept the electron. Is it possible to prepare the electron? I have taken zinc rod in a copper solution. The copper solution is 11 molar. What is the concept that Zn converted to Zn2 plus due to this free energy negative, and these 2 electrons travel to from this external wire, glow this bulb, electron reach to this point, Cu2 plus accept these 2 electrons and convert it to Cu solid. Is it possible to prepare the galvanic set like this? The answer is no. Why? Because this Cu2 plus, will this Cu2 plus wait to come down the electron to this point? No. They will accept the electron from this point. So electron gain or loss completely occur with this point. No electron will flow from external circuit. So what we have to do, we have to differentiate these or to form a barrier so that the gain and loss of electron will not take place inside the container. To do this, we have to prepare electrode half cell. We have to prepare electrode half cell. Now, how to prepare electrode half cell? And what is electrode half cell actually? If you see, this redox reaction is the addition of 2 different redox reactions. One is copper accept 2 electron to give copper solid. Second is zinc losses 2 electron to give Zn2 plus. After adding these 2 reactions, I have get this final equation. Now, Cu copper solid. This is 11. Let's say this is 0, 1, 10. The value of Kc is 10. This is the first equation. Consider the second equation. Zn is equilibrium with Zn2 plus 2 electron. In this case, I have taken this. The concentration of Zn2 plus 1 and this is 1. The Kc is 1 by approximately 1 by 9 or any value of this Kc. So if I multiplied both this equation, I will get the Kc 10. Clear? That means without taking Zn, this equilibrium, first equilibrium of copper can be possible without taking zinc. Why? Because I know that Cu2 plus, if I take a container Cu2 plus 11 molar, the concentration of this Cu2 plus want to decrease to now, if I take a solution, copper solution, we take Cu solid. This container consists of Cu2 plus 11 molar. 11 molar. Now, to achieve the equilibrium constant 1 by 10, the concentration of Cu2 plus from 11 molar, it decreased to 1 molar or 0.1 molar. Is it? From 11, it decreased to, 10. So that it will get 1 by 10. Now, we know that every container consists of free electron. So let's say this is copper electrode. This copper electrode consists of free electron. This electrode is electrically neutral, but consists of free electron in the holes due to F-center defect. Yes. if except this 2 electron, is it possible to keep Cu2 plus alone? No. It must be copper sulfate or any other solution. Let us say CuSO4 2 minus. CuSO4 2 minus. Now the concentration of Cu2 plus and SO4 2 minus both are same. The concentration of Cu2 plus and SO4 2 minus both are same. At time t equals to 0, the concentration of Cu2 plus is 11 molar and the concentration of SO4 2 minus is 11 molar. So the electrical neutrality of solution become constant. जितने positive charge हैं उतने negative charge हैं. Electrically neutral solution है. And this copper electrode, it consists of free electron and it is also electrically neutral. Any question? In the electronic conductor increase with rise in temperature. Actually, if you increase the temperature, the resistance get increases and the flow of electron will be less. Second thing, the transport number, if you calculate the value of transport number, higher the temperature, transport number will be lower. These are the two reasons. And rest I will explain in the conductance part. This is electrochemical cell part. So both Cu2 plus and SO4, the amount of Cu2 plus and SO4 are 11 molar. And I have taken a copper electrode in this solution. Both the solution as well as electrode are electrically neutral. Now, if these free electrons are absorbed by this Cu2 plus, the concentration of Cu2 plus decreases. The concentration of Cu2 plus decreases and the electrode present in this electrode are also decreases. So after some time, after 5 minutes say or 10 minutes, whatever the time, can I say the positive charge in the system or in the solution decreases and the available electron in the electrode also decreases. That means the electrode become positively charged and the solution become negatively charged due to the presence of SO4 2 minus. So I can say in this solution, after some time, the electrode is positively charged and the solution is negatively charged. That means a bilayer develop, plus minus. Bilayer develop. Due to this bilayer, the potential difference is developed, which is known as half electrode potential. Which is known as half electrode potential. Similarly, if I take the solution of Zn, zinc, and dip Zn2 plus and SO4 2 minus, and the concentration of Zn2 plus is lower than the equilibrium constant, then the solution of this Zn converted to Zn2 plus and electron left behind, and the electrode get negatively charged. So again, the bilayer formed between this electrode and this. Due to this, the half electrode potential generated. Is it clear? So to prepare galvanic cell, we have to prepare these half electrode, about 5 different types. So this is what we have discussed is metal ion electrode. Metal ion electrode. Why metal ion electrode? Because I have taken copper in the Cu2 plus solution. So this is metal ion electrode. Is it clear? So if the above reaction, I have to prepare electrochemical cell. So if the above reaction, I have to prepare electrochemical cell. I have taken a zinc electrode, which consists of Zn2 plus and SO4 2 minus, and it is connected with a copper electrode. The half cell consists of Cu2 plus and SO4 2 minus. This electron flow from this point to this point. Electronic flow like this. Anode Zn to Zn2 plus. This is anode and this is cathode. According to IUPAC nomenclature, anode will always be represented in the left hand side. So anode will be always in this position, cathode will be always in this position. So Zn2 plus SO4 2 minus. Is it clear? Now the electron will flow from Zn to copper and till the equilibrium will reach. But during this process at time t equals to 0, at time t equals to 0, the concentration of Zn2 plus is equals to that SO4 2 minus. Concentration of both are also equal. But as soon as Zn2 plus come inside the solution, the positive charge increases and interprotonic repulsion decreases Cu2 plus to come inside. So the reaction will stop. So we have taken an inert salt bridge. This salt bridge consists of iron, and these ions are Zn2 plus is from electrode come to the solution, and this Zn2 plus absorb one Cl minus or negative ion. Due to this, electrical neutrality of this solution is maintained. Is it clear? Now, I can say if I put a galvanometer or voltmeter to this solution, I can able to measure the exact E cell, which is oxidation potential plus reduction potential. All of you know E cell? All of you know E cell? So what is E cell? E cell is the electromotive force. Electromotive force. EMF. But how you define EMF? Actual EMF is when time t equal to 0. When time t equals to 0, the maximum potential of this cell is known as EMF. The maximum potential or cell potential is known as EMF. ये आवाज क्या आ रहा है? उससे करेंगे the E cell is equals to E oxidation potential plus E reduction potential. How you define E cell? This is EMF of this particular cell. Now, if you say at time t equals to 0, the free energy is minus 500 joules. When at time t equal to t, the equilibrium reach, the delta G is 0. That means continuously the delta G decreased from 500 to 0. That means after time t equals to t, if I measure the cell potential, it must be decreased as compared to initial value. That means we can able to say that the cell potential will vary every nanoseconds. The maximum cell potential must be present at time t equals to 0. At time t equal to 0, the maximum cell potential is known as EMF of cell. Is it clear? Is it clear? So let us solve some questions based on Nernst equation. The same reaction Zn plus Cu2 plus is equilibrium with Zn2 plus copper solid. Delta G naught plus 2.303 RT log QC or KC. QC or QP. Now, 2.303 and 2.3 RT log QC. Why I have written QC? Because if I put the value of KC, the delta G becomes 0. Now, when we start with the cell potential, we have told that the maximum free energy is converted to electrical energy. So can I say the delta G is the amount of charge NF passed through the potential E cell? N is the number of electron, F Faraday. This is total number of charge passed across the potential E cell minus NF E cell. And delta G naught can be written as minus NF E naught cell. This can be written as 2 E cell equals to E naught cell minus 2.303 RT NF at 25 degree centigrade temperature. If I put the value of T 298, the value of R 0.0821, that means the value can be written as 0.059 divided by N log Zn2 plus oblique Cu2 plus. If you know the value of E naught, how you define E naught? When the concentration of both Zn2 plus and Cu2 plus is 1 molar, the potential is known as E naught cell. If you know the value of E naught cell, by calculating each and individual concentration of Zn2 plus and Cu2 plus, you can able to calculate the value of E cell. Clear? Is it clear? So let us take an example where Ag/AgCl, the Ksp of AgCl is 10 to the power minus 20. Salt bridge can be written as /CS3COH 0.1 molar, CS3CONA 0.3 molar, pKa of acetic acid 5/H2 1 atmosphere. The E naught cell is 0.5 volt. E naught cell is 0.5 volt. So you have to calculate the E cell of this particular reaction according to IUPAC nomenclature. As we have already discussed that at left hand side we always write anode. So this part is anode. This is a normal representation of an electrochemical cell. Ag/AgCl means Ag is converted to Ag plus, and this solution consists of Cl minus. So they get precipitated to AgCl. If you want to calculate the exact value of Ag plus, that can be calculated from Ksp. / means salt bridge. This salt bridge, we have taken acetic acid, sodium acid having pKa 5. Both the concentration of acetic acid and sodium acid are given. It produces H2. That means H plus is converted to H2, and the pressure of this H2 is 1 atmosphere. Is it clear? And the E cell is 0.5. We have to calculate the E cell of this particular reaction if the E naught is 0.5 volt? Without writing anode and cathode reaction, never try to solve the numerical. First, let I explain this question. After that, I will ask another question. You will solve that. First, you write the anode reaction. Anode. Can I say in anode, Ag is converted to Ag plus electron? And in cathode, don't see this acetic acid, sodium acid, just see what is producing. This is hydrogen gas is producing. That means the acceptor of electron must be H plus. Can I say at cathode, 2H plus accept 2 electron to form H2? Always balance the reaction. If there are 2 electrons are absorbing, that means this reaction is multiplied by 2. Add these both anode and cathode reactions. So you can able to write down 2Ag plus gives 2H plus. It gives 2Ag plus plus H2. So this is the net reaction. After getting the net reaction, you can able to write down the value of QC. So the E cell can be written as 0.5 volt minus 0.059 upon 2. The value of N is always, remember the value of N is number of electron gain and loss. And both the number of electron gain and loss must be equal. So the value of N is 2. After writing 2, log, I can say the concentration of Ag plus upon the concentration of H plus. I haven't written H2 gas and Ag solid because solid the concentration remain constant. We cannot able to write in the Kc. So solid is omitted. Hydrogen the pressure is 1 atmosphere. So I have written 1. Can I say this 2 cancel? Now the concentration of Ag plus and H plus is the only variable in this equation to calculate the value of E cell. Can I write the concentration of Ag plus is root under Ksp of this? As we know that the silver chloride in aqueous medium give Ag plus and Cl minus. If the solubility is as we can able to write S square equal to 10 to the power minus 20, S can be written as root 10 to the power minus 20, that is 10 to the power minus 10. So the concentration of Ag plus can be written as root 10 to the power minus 20 or 10 to the power minus 10. The concentration of H plus can be calculated from buffer solution, acetic acid, sodium acetate and pK. So the pH value of a buffer can be written as pH equal to pKb or pK plus log salt by acid 0.3 by 0.1. So you can able to calculate the value of pH. Let's say the pH is 2. The concentration of H plus is 10 to the power minus 2. So write down 10 to the power minus 2. So you can able to calculate the value of E cell. So in the numerical, the only rotation exists is the concentration of these ions. So how to know which concentration? So first of all, always write anode and cathode reaction. Then add anode and cathode reaction. After adding the anode and cathode reaction, go for calculation of the E cell. Is it clear now? So as I have mentioned that the first electrode, half ion electrode. Now we are talking about metal insoluble electrode. Metal insoluble electrode. Why we require metal insoluble electrode? Let's say this is a solution. This is a solution, and I have to prepare silver chloride solution or silver chloride half cell. Just as we have prepared Zn2 plus. So in case of Zn2 plus, this is a zinc rod. I have dipped this zinc rod in a solution, and this solution consists of zinc sulfate. That means Zn2 plus and SO4 2 minus. The concentration of Zn2 plus present in this solution change the potential of this zinc electrode. Now, if I have to prepare silver chloride solution, AgCl, then I have to take this as Ag. in aqueous medium, I have to add silver chloride. But we know that the solubility product of AgCl is 10 to the power minus 20. That means in this solution, if I take 1 mole of Ag plus, or sorry, Ag silver chloride, the Ag plus available in this solution is 10 to the power minus 10. And rest all AgCl are in the precipitate form. So it is possible to prepare metal ion electrode for such salts? No. To prepare metal ion electrode for these salt, we required metal insoluble electrode. So the first metal insoluble electrode is AgCl. So how to prepare metal insoluble electrode? Look, this is a solution consists of water. We have taken silver Ag. Let's say this marker is a silver electrode. I have taken salt of AgCl, some non-polar solvent I have added and form a paste. After that, I have put the paste to this silver electrode. Now, it is dipped in a solution which consists of Ag plus. So this is a paste of AgCl. This is a paste of AgCl. And this solution consists of Cl minus. This is a paste of AgCl. This is silver electrode and this is Cl minus. Now, in general, how you define E naught potential or standard electrode potential? For zinc electrode, generally we say the concentration of Zn2 plus is 1 molar. For copper electrode, the concentration of Cu2 plus is 1 molar. For hydrogen electrode, the concentration of H plus is 1 molar. In almost all half cell, the concentration of that particular ion is 1 molar, which is taking place in the chemical reaction of anode as well as cathode. But in this case, if I say, let's say this half electrode act as anode. Anode means oxidation. Oxidation means loss of electron. So Ag is converted to Ag plus, which absorbed with this Cl minus and form AgCl. So this is the oxidation or anode. When this half electrode acts as a cathode, that means it will accept, when it will accept the electron, this AgCl paste is involved. It gave AgCl plus Cl minus. See in both the reaction. In both the reaction, the ion which is participating in gain or loss of electron is silver. So the ion which is participating in gain and loss must be present in 1 molar for standard. So is it possible to prepare a solution which consists of 1 molar of Ag plus ion for AgCl? No, because the solubility product is 10 to the minus 20. So how you define this E naught? So in general, we write down the concentration of this Cl minus ion. If the concentration of this Cl minus ion is 1 molar, the potential of this half electrode is known as standard reduction or standard oxidation potential. Is it clear? If the concentration of this Cl minus is 1 molar, the potential is known as standard. Now, if I take another salt of AgCl, let's say I have taken this solution and this consists of silver, no paste form. It consists of a salt which is 100% ionized, like silver nitrate, AgNO3. This AgNO3 is 1 molar. This is salt. This is what we call metal ion electrode. In the metal ion electrode, the ion is 1 molar. So the E naught will be 0.8, let's say. So can I say the E naught of this is also 0.8? In this case, how you define standard? The concentration of Cl minus is 1 molar, then the potential is known as standard. In this case, how you define standard? The concentration of Ag plus is 1 molar, then it is known as standard. Both the electrode are the example of silver or metal ion electrode, but both the oxidation potential are different. So is there any relation between the oxidation or standard reduction potential of this and standard reduction potential of this? So we have to calculate, or we have to find out the relation between both the standard reduction potential of these two ions. Is it clear? Now how to calculate the relation? To know the exact E naught potentials, let us take an example of a reduction potential of silver chloride. AgCl. Accept an electron to give Ag solid plus Cl minus. Is it clear? you can able to calculate the value of delta G naught 1. Delta G naught 1 can be written as minus NF E naught AgCl slash Cl minus. Is it clear? This is the first equation. One more equation we can able to write. Ag plus electron give rise to Ag solid. This is the reduction potential of a standard silver. So the delta G naught 2 can be written as minus NF E naught Ag plus slash Ag. This is delta G naught 2. But both the reactions are reduction potential of two different ions. Third equation, silver chloride AgCl is in equilibrium with Ag plus and Cl minus. The value of delta G naught 3 is minus 2.303 RT log Ksp. Can I write? Minus 2.303 RT log Ksp. Why Ksp? Because silver chloride give Ag plus and Cl minus. This equilibrium is one kind of solubility product. So, can I say if I minus 1 minus 2 is 3, equation 1 minus equation 2 equal to equation 3. You can able to think that why I have calculated free energy delta G naught. If I write E naught, always remember if you add two reactions, the delta G naught may be add. We can able to add. If you add two reaction, enthalpy of both the reaction may be addition. If you add two reactions, the entropy may be addition. That means all thermodynamic quantities are added when the two reactions are added. But the oxidation and reduction potential are not the thermodynamic quantities. So if you add two reactions, the oxidation or reduction potential are never the sum of these two. Maybe the sum of, but may not be possible, right? So in this equation, I can able to say equation 1 minus equation 2 can be written as delta G naught 1 minus delta G naught 2 equals to delta G naught 3. Due to this reason, I have converted this to free energy. Now, delta G naught 1, this can be written as minus NF E naught AgCl slash Ag minus minus plus E naught Ag plus NF E naught Ag plus slash Ag minus 2.303 RT log Ksp. Is it clear? So E naught AgCl slash Ag can be written as minus NF E naught Ag plus slash Ag minus 2.33 RT log Ksp. I will divide both sides NF minus NF. So if I divide both sides minus NF, I can able to get E naught Ag slash Cl slash Ag equals to E naught Ag plus slash Ag minus NF. I divide. This will become plus 2.303 RT NF log Ksp. Clear? So look this reaction, this equation. You can able to calculate the electrode, half electrode potential of an insoluble metal and a relation between when the Ag plus is present along. So you can able to get this relation. Is it clear? Clear? So there is a concept of electrochemical cell and there is a concept of electrolytic cell. There is a cell which acts as electrolytic when it is charged, and upon discharging it acts as electrochemical cell. Clear? So such cell is known as lead storage battery. Lead storage battery is a very common concept based on which the numerical is asked. Correct? How you define lead storage battery? Assuming that I have taken a lead storage battery, one compartment consists of lead, Pb, and another compartment consists of lead oxide, PbO2, and the solution is sulfuric acid. Solution consists of sulfuric acid, H2SO4. This is lead, this is PbO2, anode and cathode. So this battery may act as two types. One is electrolytic solution and second is electrochemical solution. When it acts as electrochemical solution, it produces electricity. When it is taken as electrolytic solution, it converts electrical energy to chemical reaction. Now first let us consider this as an electrochemical cell. If it is an electrochemical cell, it produces electrical energy. So if we produce electrical energy at anode, this lead react with this solution of SO4 2 minus. This SO4 2 minus is present in the solution. So this lead react with SO4 to give PbSO4 plus 2 electron. PbSO4 plus 2 electron. At cathode, this PbO2 accept 4H plus in presence of H2O to give PbSO4 plus 2H2O. So this is anode oxidation, lead is converted to PbP2 plus, and this is cathode reduction, PbO2 from plus 4 oxidation state to plus 2 oxidation state. Clear? Can I say, when we release the electrical, when it converted to electrical energy, chemical energy to electrical energy, the weight of this lead decreases, the weight of this cathode is also decreases. Both Pb and PbO2 are converted to PbSO4. If you add this reaction, you can able to get that one molecule of sulfuric acid, 4H2SO4, 2 molecule of H2SO4, converted to 2 molecule of water. So the density of sulfuric acid also decreases. When this acts as an electrochemical series, when this solution acts as electrochemical series, we are adding electricity. At that moment, the electron enters to the Pb compartment and released from PbO2. If it enters from Pb compartment, the PbSO4 in the solution absorb these 2 electrons and convert it to Pb. The weight of Pb again increases and SO4 present in the solution. And the solution which is present in the PbSO4, it accepts or it reacts with water to convert PbO2. Weight of PbO2 increases and free H plus and SO4. Increase the concentration of sulfuric acid. And this battery is being charged. So it acts as electrochemical cell, it acts as electrolytic cell. So based in this concept, solve this numerical. During the discharge of a lead storage battery, the density of sulfuric acid decreased from 1.2 to 1.13. Sulfuric acid density 1.2 is 39% H2SO4 by weight, and the density 1.3 is 20% weight. The battery can hold 3.5 liter of acid. The volume remain practically constant during the electrolysis. So you have to calculate the total energy released. Current. Can I say Pb plus PbO2 plus 2H2SO4 give 2PbSO4 plus 2H2O? During this reaction, number of moles of electron participate in this reaction is 2. Can I say if 2 moles of sulfuric acid consume, 2 moles of electron transfer will be take place? That means the number of moles of H2SO4 consume equals to number of electron transfer equals to quantity of electricity, moles of electron, Q or Faraday. Is it clear? So look at the numerical. During the discharge of lead storage battery, the density of sulfuric acid is 1.29. When the density is 1.294, when the density is 1.294, sulfuric acid is 39% by weight. Can I say the volume is 3500? Because it is mentioned that the battery can hold 3.5 liter of water. Can I say the total volume of this liquid is 3500 ml? This multiplied by 1.294. This is the total weight of solution. This multiplied by 39 upon 100. This is the total weight of H2SO4 present in 3.5 liter of container divided by 98. Now this is total number of moles of sulfuric acid present in 3.5 liter of water at time t equals to 0 when this reaction is not started, right? Again, 3500 multiplied by 1.139. This is the weight of solution after the battery is consumed, multiplied by 20 upon 100 into 98. So this is the moles of H2SO4 left. This is initial mole of H2SO4. This is mole of H2SO4 left minus this. This is the mole of H2SO4 consumed. The number of mole of H2SO4 consumed equals to number of electron transfer take place equals to number of Faraday of electricity produced from that particular battery. Is it clear? Clear? Next. 5. Actually, this is the equilibrium sign. This is the equilibrium sign. You have to calculate the Kc of this particular equation. The two data given are E0 Ce4 plus to Ce3 plus. From these two data, you have to calculate the equilibrium constant for the reaction Fe2 plus Ce4 plus, equilibrium with Fe3 plus Ce3 plus. Very easy question. Fe2 plus to Fe3 plus. This Fe2 plus to Fe3 plus. This is the oxidation. And the reduction potential is 0.64. That means the oxidation potential will be minus 0.68. C plus 4 to plus 3, this is reduction. And the reduction potential is 1.44. That means the E cell will be 1.44 minus 0.68. Now we can able to calculate delta G naught can be written as minus NF E naught. I think this is all oxidation reduction potential are in the form of E naught. So delta G naught minus NF E naught. N is 1. So E naught cell is, you can able to calculate delta G naught. We know that delta G naught is minus 2.303 RT log Kc. So from this data, you can able to calculate the value of Kc. Is it clear? Next question. Again, the sign is equilibrium. You can say this is also based on the equilibrium constant. So if you want to calculate the equilibrium constant of this, the oxidation potential, reduction potential are given. You can able to calculate the E naught cell. Based on that particular E naught cell, you can able to calculate delta G naught. From delta G naught, you can able to calculate Kc. Simple. Next. This required time. Zinc granules are added in excess of 5. Simple question again. Solve. Actually, in this question, if you see the reduction potential of Zn and nickel are given, can you able to calculate the E cell of this reaction? E cell. I can say the E cell is E naught cell is E naught Zn slash Zn2 plus E naught Ni2 plus slash Ni. Both the value are given. So you can able to calculate the value of E naught. From E naught, you can able to write minus NF E naught is delta G naught. From that, you can able to calculate the value of Kc. Look, this is a solid, so the concentration remain constant. Now I have taken the concentration of this Zn2 plus is Ni2 plus is 1 molar. 1 minus 2 alpha alpha. Alpha by 1 minus alpha can be written as Kc. The value of Kc can be calculated. So you can able to find the value of alpha. Simple. So this is all about electrochemistry and some part of redox. So we end our lecture today, and tomorrow we will start chemical kinetics. Right? Thank you.